is the title of our group assignment, which is complementary metal oxide semiconductor that we call as CMOS. So this is the content of our presentation. First, we will talk about the introduction of the CMOS. Next, circuit diagram and device use, followed by function of the circuit and device. Lastly, the application of the CMOS. What is CMOS? CMOS is the one of the most popular MOSFET technology. CMOS is the combination of NMOS and PMOS in a single device. CMOS technology is used as the microprocessor, microcontroller and other digital logic circuit. We use this CMOS in our computer and also our mobile phones. Although early microprocessors were made using NMOS, CMOS has completely replaced it. So these is some of the characteristics of the CMOS. First, it has a low power consumption. Second, high noise immunity. Last, fast and cheap. The phrase metal oxide semiconductor is referred to the physical structure of certain field effect transistor having a metal gate electrode placed on top of an oxide insulator, which in turn is on top of a semiconductor material. We can see this from the figure below.
Hi, now we're gonna talk about circuit and devices of CMOS. As we know, CMOS is integrated circuit that consists PMOS and NMOS. As we know, MOSFETs contain of PMOS, NMOS, and CMOS. So, CMOS is advanced devices that contain NMOS and PMOS in their devices. So here is the circuit diagram of the CMOS. We have a P channel and N channel. So, source, we have a source, gate, and drain. Source and drain function to control the current enter and leave the circuit, while the gate is also control the current flow. On off depend on the voltage applied to the gate. So current can flow from the source to drain or drain to source, depend to the type of MOSFET. Okay, this is a cross section of PMOS and NMOS. So as we can see here, PMOS is connected to the most positive supply voltage in MOS circuit. So there we know that P channels connected to VDD. So for the NMOS, this is a reverse bias, the PN junction, so it connected to the ground. Next is a CMOS structure. As we know, in a PMOS, they have an N-type substrate connected to the positive supply voltage. And for the NMOS, they have a P-type subset that were connected to the ground. So each source, drain, and gate is actually isolated from the body of a transistor. So they have a silicon dioxide and also polysilicon or metal used.
Before I explain about the working principle of CMOS, I will explain a little bit about NMOS and PMOS because NMOS and PMOS is quite related to CMOS. So for the NMOS, majority carrier are electron. If high voltage is applied to the gate, NMOS will conduct. So for the PMOS, majority carrier are holes. If high voltage is applied to the gate, PMOS will conduct. So this is actually the working principle of the CMOS. In CMOS, both N-types and P-type transistors are used to design logic function. The transistors are used as a switch which turn on a transistor of one type and turn off a transistor of the another type. This characteristic allows the design of logic device using only simple switch without the need for a pull-up resistor. Actually, this is a simple circuit for the CMOS that I draw. So PMOS is a part of N-type substrate, and NMOS is a part of P-type substrate. So what we know about this inverter, actually this is an inverter. So when we input something, it will give us opposite effect. So PMOS and NMOS are sharing the same input. This input, they actually share the same input. So we set the input as low. The PMOS will give the output as high. So when the entire transistor is closed, the transistor will turn on and the voltage will travel across the PMOS to the output. So for the NMOS, the input is low and the NMOS transistor for that is open. So the transistor will be turned off. So the ground doesn't travel to the output. So actually the inverter is basically formed by having NMOS and PMOS formed together, and these things create what we call as CMOS. So that's all.
This is some of the application of the CMOS. We can see the CMOS in the integrated circuit, image sensor, computer memories, microprocessor, and the logic circuits.